In this lesson, we want to discuss sum to infinity of a geometric progression, or sum of an infinite geometric progression. Okay, so that is the objective of the lesson. So now, remember that sum of nth term of a GP is given as Sn equal to a into 1 minus r raised to power n all over 1 minus r for r less than 1. Now, as n increases, r raised to power n decreases. Okay, as n increases, r raised to power n decreases. Okay, so this is what we mean by that. So if your n is 1, and let's say r is 1 over 2, so Rn here will be 1 over 2, which is 0.5. So if your n becomes 2, Rn will be 1 over 2 raised to power 2, which is 1 over 4, which is 0.25. And of course, you can see that this is greater than 0.5 is greater than 0.25, so Rn is decreasing. If your n becomes 3, you have r raised to power n to be 1 over 2 raised to power 3, which is 1 over 8, which is 0.125. and you can see from here to here that 0.125 is less than 0.25. okay, so there is a decrease. It's actually decreasing, so it decreases. So this statement here is true. So now, as n approaches infinity, Rn will approach 0. Okay, so therefore S infinity will become a into 1 minus 0 all over 1 minus r, which is a into 1 all over 1 minus r, and of course that is given as S infinity equals to a over 1 minus r, and that is the formula for calculating the sum to infinity of a geometric series. Okay, this is the formula. So with this formula, you can calculate the sum to infinity of a GP or any GP. Let's take a look at these examples. Example 1. The first 4 terms of a geometric progression is 3 minus 1, 1 over 3 minus 1 over 9. Find the sum to infinity. Okay, so solution. Let us write down the sequence. 3 minus 1, 1 over 3 minus 1 over 9 is the sequence. Okay, the first term of this sequence is a, which is 3, and the common ratio is minus 1 over 3. So sum to infinity by formula is a over 1 minus r, and this is 3 over 1 minus 1 over 3, which is 3 over 1 plus 1 over 3, because this is 3 over 4 over 3, and that can be given as 3 over 1 times 3 over 4, which is 9 over 4. Therefore, sum to infinity of this GP is 9 over 4. A geometric progression has a common ratio of 3 over 4, and sum to infinity of 92. Find the first step. Okay, let's write down what we have. Common ratio is 3 over 4, and sum to infinity is 92. Okay, find the first term. So we use the formula of sum to infinity, which is a over 1 minus r. So therefore 92 equal to a, we don't know a, over 1 minus 3 over 4. Okay, which is the same thing as 9 over 4 minus 3 all over 4. Okay, and this is just 9 over 1 over 4. So of course 92 equals to 9 times 4 over 1. A times 4 over 1. Okay, it's A, not 9. All right. So 92 equals to A over 1 times 4 over 1. So we can have 4A equals to 92. So dividing both sides by 4, we have 4 in 4, 1, 4 in 9 is 2, 4 in 12 is 3. So A equals to 23. So the first term of the GP is 23. A geometric progression has a sum to infinity of minus 30. The last term of the geometric progression is minus 9. Find the common ratio. The geometric progression has a sum to infinity of minus 30. So the sum to infinities of this GP is minus 30. The first term of the geometric progression is minus 9. First term is minus 9. And the common ratio R, we don't know. So find the common ratio. So from the formula of sum to infinity, which is A over 1 minus R, we can find R. So we substitute what we have into the formula. We have minus 30 equals to minus 9 over 1 minus R. Okay, so we can cross multiply here to have minus 30 into 1 minus R equals to minus 9. And of course minus goes in minus, so dividing both sides by 30, we have 30 goes in 30 here, so 1 minus R equal to 3 here, 3 here, 10, 3 over 10. So therefore 1 minus 3 over 10, subtracting 3 over 10 and adding R to both sides, we have 1 minus 3 over 10 equals to R. So therefore R equals to 10 minus 3 all over 10, which is 7 over 10. So therefore the common ratio is 7 over 10. Calculate the sum to infinity of the series. Okay, so the series is given thus. So looking at the series, the first term is 127, 125. The common ratio, our second term over first term, which is 25 can go here, 25 here, 3, or 25 in 125 is 5. So common ratio is 3 over 5. Okay, so we are asked to calculate the sum to infinity. Sum to infinity, S infinity by formula is A over 1 minus R. So that will give us A, which is 125 over 1 minus 3 over 5, which is 125 over 5 minus 3 over 5, and that will give us 125 over 1 divided by 2 over 5, which is 125 times 5 over 2. Okay, and of course 125 divided by 5 over 2 altogether will give us 125 divided by 5 over 2. Altogether should give us something like 125 times 5. This is 625 over 2. 625 divided by 2 will give us 312.5. So therefore sum to infinity of this GP is 312.5. And that is our examples, guys. So remember to click the subscription button below and put on the notification to get to get our next video, which is going to be inequalities. See you then. Bye. Study and pass your exam.